Hi guys, we are on lesson 12. It is on page 113 and it is called Choice of Unit. And we start off on exercise 1 pretty quickly with an example where you're trying to decide which unit you might use. So let's look at this. A certain brand of MP3 player will display how long it will take to play through its entire music library. If the maximum number of songs the MP3 player can hold is 1,000 and the average song length is 4 minutes, would you want the time displayed in terms of seconds, days, or years worth of music? And explain. So like it's the difference between seeing like if you said like, oh, this is 240,000 seconds worth of music, or 5 657ths of a year worth of music, or 2.8 days of music. So like this is just an example that which one would you prefer to see on an MP3 player, like which one makes more sense than you, and most likely you would say, oh, this one would make more sense. Just that we can think about that in terms of every day and realize that that's probably the way that we would want it explained, whereas these two are kind of hard to imagine how much time that really is. Okay, so most likely that, because the other two are difficult to understand. Like the magnitude of how many songs that would be. Okay, exercise 2 is similar in that you have been asked to make frosted cupcakes to sell at a school fundraiser. Each frosted cupcake contains about 20 grams of sugar. Bake sale coordinators expect 500 people will attend the event. Assume everyone who attends will buy a cupcake, which is like 20 grams of sugar times 500 people, right? And so it's asking, does it make sense to buy sugar in grams, pounds, or tons? And if you've ever gone to the grocery store, it makes sense, and bought sugar, you know that sugar comes in pounds, like you would buy a pound of sugar or 2 pounds of sugar. Definitely grams would be too small. This is how I'm going to explain it just briefly. And tons would be too big. And so pounds would be just the right measurement, right? Sugar should be purchased in pounds. Okay, and then the next one, the seafloor spreads at a rate of approximately 10 centimeters per year. If you were to collect data on the spread of a seafloor each week, which unit would you use? So if it's 10 centimeters per year and you're looking for each week, you would use something probably smaller than centimeters, right? And what is smaller than centimeters is millimeters. Is a smaller unit than centimeters. So that's probably what you would use. Okay? All right, on the other side, it gets a little complicated really fast, so I kind of prepared the problem just because it has some different ideas that maybe you've never heard of, unless you're like an engineer. Okay, so or a physicist. We have the giga electron volt, which is GeV divided by c squared, is what particle physicists use as the unit of mass. And 1 giga electron volt is equal to that. The mass of 1 proton is equal to that. So it's asking you to show that the mass of a proton is 0.938 of this amount. So if we let x represent the number of giga electron volts equal to the mass of a proton, it would be x times the giga electron volt is equal to mass of a proton. And so x times the giga electron volt, which is there, is equal to the mass of a proton, which is there. And now to figure out x, you would divide both sides by this, 1.783 times 10 to the negative 27, 1.783 0.783 times 10 to the negative 27. Okay, and this would cancel out over there. And over here, by dividing these two, you are going to get approximately 0.938, and then this will cancel out. And so this is there. That's the, it's showing that it is equal, and that's how you show it. Okay, and the next one is similar in that in popular science writing, a commonly used unit is the light year, or the distance light travels in 1 year. Note 1 year is defined as 365 1/4 days. So 1 light year is equal to that number, which is that number in scientific notation. So the distance of the nearest star, which is Proxima Centauri, to the sun is approximately this number. Show that Proxima Centauri is 4.2421 light years from the sun. So that's what we're trying to get. So we're letting x, I didn't write that, represent the number of light years PC, Proxima Centauri, is from the sun. So if you say x, and then you're multiplying it times the number of light years, then it should equal the distance of that star, right? So if we do this, we're going to divide 9.46073 times 10 to the 12th power by both sides. And if we divide this here, we are going to get 0.42421 times 10 to the 1th power. 13 minus 12 is 1, which if you just multiply that out, it is approximately 4.2421. We could stop there because that is this. And so you proved it. Okay. The next page, unfortunately, is exploratory, and while we can do it in a classroom, it's really hard virtually, so we're just not. We're canceling the exploratory challenge out. And after that, you guys just have your assessments for lesson 12. All right, bye.